Thanks for joining us on our discussion of precipitation measurements. We are talking about snow right now, and we are still working our way through theory. There was one previous video that discussed snowfall theory and the terms that we use. We're going to go through some more terms right now. And the first one that we're going to talk about is water equivalent. Water equivalent, as we discussed in the previous video, we talked about snowfall and snow depth. Those are two very important definitions. Snowfall is the new snow or recent snow, whereas snow depth is what is on the ground. So when we talk about snowfall water content, that implies that it's new snow. And by definition, snowfall water content is the water content of new snowfall since the previous day's observation. And we also call this the snowfall water equivalent or snow water equivalent. You'll see SWE. And in the United States, we use inches and we measure the resolution to the nearest 1/100th of an inch of water. Snowfall water content can be measured, at least at the National Weather Service. It's measured by the 8-inch standard snow gauge. How is that different than the 8-inch standard rain gauge? Well, actually, it's the same thing. But what they do is they take out the funnel. I don't know if you recall when we were talking about the 8-inch standard rain gauge, there was a funnel that goes into a measuring tube. During the wintertime, they take out that funnel and they take out the measuring tube, and then they just leave the can open and let the snow fall into the can. Another term you need to be familiar with is snow density. Snow density is the ratio of the volume of the meltwater that can be derived from a sample of snow to the original volume of the sample. And here it talks quite a bit about volume and the ratio. So it's the ratio of the water divided by the ratio of the snow. Not the ratio, but the volume of the water divided by the volume of the snow. If your area is the same, for example, if you're looking at the 8-inch rain gauge, it has a standard opening, and you'll have that opening for snow to collect, and then when you take it inside and melt, that opening will be the same for water. So the area is the same. If the area is the same for both of these, that means that it's just a height ratio. The height of the water divided by the height of the snow. You can also multiply that by the density of water in grams per meter cubed, which is actually 1, and then you'll get a unit that you'll have the density, snow density, in terms of grams per meter. I don't see that very often. I don't see it multiplied by grams per meter cubed. Usually we just look at the ratio and that's it. So here's some numbers for you that you can kind of use and get a feel for snow density. Think about this. Snow density is the amount of water divided by the amount of snow. So if you think about ice, you know that if you freeze ice, it'll expand. Many people have learned that after they left a beer in their car overnight. It'll explode, it'll expand, right? So similarly, water expands when it freezes. So if you have 1 inch of water, when you freeze it, it'll be a little bit more. So your density of water divided by ice is more, you'll have a lower density of ice. Ice has a lower density, and that's 0.91 for pure snow or for pure water or glacial ice. I guess you can look at it that way. However, when snow is falling, the density is very, very low. You think about it, there's a lot of air in between those ice crystals. So when they fall, there's still a lot of space between it. So with our really wet and sloppy spring snowfalls, you have a much higher density. It goes anywhere from 0.1 to 0.3. But during the wintertime here, at least in North Dakota, when you get really light and fluffy snow, the density of snow is very, very low, and it can be anywhere from 0.07 to 0.15. There's another term that we use. It's the snow to liquid ratio. It's the ratio of the snow depth to water equivalent. We use this in forecasting to estimate the amount of snowfall based upon water equivalent, or what's falling out as the models are showing in water equivalent. So we call this also the snow to rain ratio, or the water equivalent ratio. And simply it's the inverse of the snow density. So here's an example. Let's say that it snowed 10 inches, we melted that down, and we came up with a snow water equivalent of 1 inch. So the density would be 1 divided by 10, which is 0.10. But the inverse of that would be your snow to liquid ratio. So put the snow on top and the liquid, or more often what we do is we don't really divide it, but we use a colon to represent the ratio. So snow to water, or snow to liquid ratio of 10 to 1, where it would be where you get 10 inches of snow from 1 inch of water. There are a lot of factors that determine the snow to liquid ratio, or for that matter, the snow density. The inverse is the snow density. And these factors are things like the location, the temperature, what type of ice crystals are you getting? Are you getting the really big flakes, or are they just little things? Also determined by the cloud microphysics, how the cloud is producing ice crystals and when they fall out, what they look like. You can think that, you can just imagine that during the springtime when the temperatures are much warmer, closer to 32, you get really big flakes. And as a result, the snow density is a lot higher. But during the winter time in North Dakota, when it's minus 40, the air is very dry and we get little crystals that don't stick to each other, and the snow density is very low. So there are a lot of other factors, but I want you to just keep that in mind. Also, this is an important factor when you're forecasting snow, because typical models give you the water equivalent but don't give you the snow equivalent. You have to come up with an estimate for the snowfall. There's another water equivalent. We talked about the snowfall water equivalent, and snowfall implies new snow. What about the snow on the ground? That's old snow. It's been sitting there all winter. We call that the snow depth water equivalent. Or if you are a weather observer, we call that the snow core, the dreaded snow core, because you don't want to go out when it's minus 40 and take a snow core measurement, because it is not fun, especially in the middle of a blizzard, and I have done that. So basically what the snow depth water content is, it's the water content of new and old snow on the ground measured by taking a snow core, a core sample. So we call this the snow depth water equivalent. And this is what you do. You take that 8-inch can, the standard rain gauge, you turn it upside down, and you plunge it into the snow and try and hit the ground, or at least ice perhaps at the bottom. So you push it down as much as you can. Here it says snow tube, but we also use an 8-inch rain gauge to measure, or to get a core sample. And then what we do is we dig along the side and then put a board underneath to catch the snow, so that as we pull it up, all the snow stays in there. And then we go inside and we melt the snow, leaving it in the can. And then we measure the water that is in the can. So we measure the snow depth, and then we measure the depth of water. Here it says it's the volume of the melt water divided by the area. But what we do, remember the area is constant, so it's really just the depth of the water from a particular measurement of snow, or a depth of snow. So here's our depth of snow. We take it inside, we melt it, we get water, and then we already measured how deep the snow is on the ground just with a ruler. And then we measure the water in the can after we melt it, and that is our snow depth water equivalent. Snow depth water equivalent is extremely important here in North Dakota, in the Red River Valley, and many other places in the north, where during the springtime we are really concerned about the snow melting and producing a flood. So this is used in hydrology whenever we make a measurement. Well, every day we make a measurement of snow depth water equivalent, and then that goes into the computer models to figure out the flooding in the spring. It estimates the snowpack, how much water is in that snowpack. This winter, here in North Dakota, when we were so concerned about flooding in the spring, I was measuring 3 to 4 inches of water in the snowpack that we had on the ground. And we use the 8-inch rain gauge, or we use also snow tubes. And as I mentioned, it's very important for determining the seasonal snow melt. So that's a little bit about snow water equivalent. Make sure you're familiar with the two, the snowfall water equivalent and the snow depth water equivalent, and also the snow density.